Hi everybody, I just wanted to record a video to give an introduction to the Planet Hunting with Python project, and in particular to give you a bit of a description about what the different files are that we've provided for you, just as a way of introducing the project and to get you started. Obviously, we're going to be doing visits to schools, either myself or George Turpin, who's a PhD student in the astronomy unit at Queen Mary, working in the field of exoplanets. So you'll have plenty of assistance with either George or myself visiting the school, but I thought it'd be useful just to get you started with a short video introducing the project and the various resources that we have provided for you. So hopefully on the screen you can see that I've got my web browser open. The first thing to note is that the project really needs you to use the Google Chrome web browser. That's just for technical reasons to do with the software that we're using. So if at all possible, do please try to use that web browser for the project. I personally have found it difficult to use other web browsers, so Firefox, or if you're working on an Apple computer, then Safari doesn't seem to work quite as well as Google Chrome. So do try to use that if possible. So on the screen, you can see that we've got the basically the website that hosts all of the files that we're providing. In particular, what we call the Jupyter notebook. So the first thing that I'm going to do is to log in. So hopefully this is something you've managed to do already. If not, please let your teacher know you're having problems, and your teacher can get in touch with me and we can provide some help if you need it. But hopefully the instructions we provided are pretty straightforward. If you've not yet set up an account, then when you go to the web browser that we're which is hosting the project, then you can go here and you can create an account by just clicking here on the left-hand side. You can enter the secret token that we provided, your name, address, and your password. I've already done that, so I don't need to do that, and the system remembers that I've logged in before, so I'm just going to log in. So when you log in, hopefully you should see a project which is named after your school, and I've got a bunch of projects which are all shown on the screen here. And what I'm going to do now is go into a project that I'm going to use, that I've set up, that I'm going to use to give you an introduction to what we're doing here. So when you click on the name of your school, hopefully you should see something that looks like this, which is on the screen now. It's a collection of folders which are named after different groups, and also one folder for your teacher. Hopefully by now you've been given the name of the group that you're going to be in. So let's assume, for example, that you're going to be in group 1, in which case I would just click on group 1 here, like this. And that will take me into the folder, and this is where you'll see all of the files and some of the subdirectories or subfolders that we've provided for you. So first of all, I just want to talk a little bit about how to navigate your way around the system a little bit. It's going to take a little bit of getting used to. But one way to navigate backwards and forwards between the group that you're in and also the project home directory, as we call it, or the home folder of your school's project, is to just go here at the top. And if you click on group 1, you'll go back to the files that you can see. And if you go back here, you can see you enter that directory or that folder where all of the groups are stored. So that's one way of going backwards and forwards. So I'm going to go back into the group now, group 1. And I'm going to talk a little bit about the folders and the files that we've got contained here. So the first thing I want to do is show you that we have in this folder another folder called data. And that's where all of the data that we have provided for you is stored. So I'm just going to click on that and show you what that looks like. And again, if you go inside of that, you see a whole load of different files with some funny looking names on them. The first one that we're going to look at is this file down here. It's called KIC 0069222244. That means Kepler input catalog, and then a serial number after it, which refers to a particular star in the sky. And that contains the data that we're going to be working with. And this particular system is one that we'll use basically to do our initial training, so that once we've learned how to analyze the data from this system, we'll then be able to apply our techniques to all of the other systems which are shown in this directory. You can see I've got KIC for some of the names and TIC. So KIC means Kepler Input Catalog. That's data from the Kepler mission. and TIC is test input catalog. So that's data from the test mission. So let's go back to this one that I was mentioning before, 0069222244. And I'm going to just click on it. And when I do that, it's going to open the file. And you can see what the file looks like. And I'm going to make sure that I scroll to the top because it seems to remember that I've been in here before. Just move some of this stuff around. And you can see that basically what we've got is a whole bunch of numbers. And if I scroll to the top, hopefully it will allow me to do that. There we go. You can see that at the top we've got 3 rows, which is basically some garbage which has been sort of spat out by the computer that's done the analysis for the Kepler mission to create this file. So we're going to just ignore those 3 first lines. And then you've got 3 columns of numbers. The first column, again, is just some garbage that we can more or less ignore. The second column contains a set of numbers that start at 131.513, blah, blah, blah. Okay, that's basically giving us a time at which a measurement of the brightness of a star has been made by the spacecraft. And then after that, we've got the measurement of the brightness of the star in some slightly funny units, which I'll talk about at some point, perhaps later on in the video. And what you can see is there's many, many lines. Each line shows a time and the brightness of the star, a time, a brightness of the star. So that's what the data files look like that we're going to be operating with or working with. So let me close that file now. Just to remind you, there's about 65,000 lines of data in each of these files. There's quite a lot of data there. They're spanning 3 or 4 years of observations that Kepler was operating for. So that takes us back into the folder with all of the data. There's one other file in here that you need to know about. I'm just going to click on it. It's called Stellar Mass Radius. And this provides us with information about the star in terms of its mass, measured in units of the solar mass, and radius, measured in units of the solar radius, for each of the systems for which we provided data. That will be useful at a later stage in the project, but I thought I would just point out that that is available. So when you need that data, you can just come into that folder and click on that file, and it will open in that way. So I'm going to go back into the main Group 1 folder, and I'm going to present for you the different what we call Jupyter notebooks. So there are 4 that you're going to be working with. The first one that's the most important for getting started with Python, particularly for students who may not have used Python before, is the one called Getting to Know Python. So that gives us an introduction into how Python operates, and in particular, it gives us some understanding of how these Jupyter notebooks operate. So just to let you know, a Jupyter notebook is just really a kind of a programming environment where we can actually type in our Python commands and get the results of those commands presented on the screen within a web browser, just like you're doing here at the present time, or like I'm doing at the moment, as you will be doing when you start to work on the project. So that's the first one, Getting to Know Python. So as I said, an introduction to programming with Python. The next one that we're going to look at is Kepler Data Intro. So that's this file here. Then the next one will be Obtaining Planet Parameters, which does exactly what the title suggests. It tells us about the different planet parameters we can obtain from the data. And then finally, Kepler Guided Exercises. So this is the final file that we'll look at, which gives you a series of exercises for analyzing Kepler data, just to give you, if you like, a sort of a mini project to get on with in a very structured format, which will then allow you, I hope, to move forward and work on the rest of the data that we provided in your own time. So in order to open one of the Jupyter notebooks, just click on the file now. It takes a little time to open up, but once the Jupyter notebook is opened, you should see something like this on the screen. So the first thing I want to say is a Jupyter notebook is something which is a programming environment where we can type in different types of commands and get the computer to give us some output from those commands. It allows us to do plotting on the screen. So when we ask the computer to plot some data for us, we can see the plot straight away on the screen. And we can also interact with that plot. There is a way of creating what we might call an interactive plot, which allows us to zoom in and do measurements on the data that's being plotted. And that's going to be very useful for us when we want to analyze the Kepler data. I also want to say that Jupyter Notebooks provide two environments in which you can type commands. Or if you like, there are two types of what we call cells, because it's the cells that we type the commands into. So when you look at the screen in front of you right now, you can see that I've got this text in front of me. It's called Welcome to Python, or this is this at the beginning says Welcome to Python here. Then we've got Jupyter Notebooks. And there's all sorts of description of what the project is about and how to use the project, and also some programming exercises which are encoded in what we call these called markdown cells. So a markdown cell is where you basically put text. And it's not really where you put Python commands, but there are certain types of commands that you can use in the Jupyter Notebooks to create the different types of text. So you can see we've got larger characters here, which are in boldface, slightly smaller characters here, and smaller characters here, which are in boldface. And then we've just got ordinary text as well. And then down here, we've got things that look like Python commands, which are not actual Python commands because they're in a markdown cell. I'll talk about the alternative type of cell in a moment. But the point is here that there's a way of using these markdown cells to create nice looking text. The other type of cell that we have is called a code cell. That's where you actually type in a real Python command, and then you can execute that cell. And in both types of cells, once you've put in your commands, the way that you execute it is to make sure that your cursor is clicked onto the cell that you're interested in, and then you press the Shift button, and then you press the Enter button. And then that generates, or that creates the output after the computer has executed the Python command. So here you can see that I've got, perhaps if you can zoom in a little bit and see the video on a larger scale, you can see that there's a command here which basically tells the computer to print the words "Hello World!" exclamation mark. And I could just edit that by saying, for example, "Hello World" and the whole universe, like that. You'll see that I've changed the text. And now when I press Shift and Enter, then just below the cell, the computer prints out "Hello World" and the whole universe, just as I've asked it to do. So that's how you actually execute a Python command. You just type the command into one of these code cells, and then it prints out the, executes the Python command and does what it asks. And if it asks to print something out on the screen, it will just get printed down below the cell that you've just executed. Let me just go back very quickly to these markdown cells and show you exactly how to look behind the scenes to see how this was created. So if I go onto one of these markdown cells, I'm just going to click on it like that, and that will highlight it. And then I'm going to double click it. And when I double click it, you'll see that behind the scenes, there are these commands that we've input into the markdown cell. And you can see that the different types of text are basically created by using different numbers of these hash symbols here. So one of them gives you a large bold-faced text. Using two of them creates what I would call a medium-sized bold-faced text. Using three makes it smaller. And if you just want to put ordinary text, you just type ordinary text in there. And to execute this markdown cell, you just do Shift and Enter again. So when I do that, you can see that it converts the text that was there previously into this nice looking text. So you take those commands and create this nice looking text. So we've got these two types of cells, markdown cells and code cells. Now, if you want to insert a cell at a certain position, so let me go here, for example, and I want to put a new cell just below it, and I want that cell to be a code cell, then I can go here, I can go and say insert cell below. And you can see that that creates for me, automatically it creates a code cell. But if I want to change this type of that cell, then I can go to here, I've got a menu item here called cell, and I can go down here to cell type, and I can convert it into a markdown cell if I want to. If I want to delete that cell, then I can go up to the menu here. I can go to edit, and there should be a delete cells command there, and I just get rid of it like that. So it's possible to use these editing commands to create cells, to change the type of cells, and to delete cells if you want to. It's going to take a little bit of time for you to get used to using all of these commands and to navigate your way around. But basically, if you've used something like, I don't know, Microsoft Word, things like that, then the environment looks a little bit similar to what you may be used to. So let me just say a few words about this notebook before I finish off talking about this one and move on to the next one. So the whole idea of this one is to give you an introduction into how these Jupyter notebooks operate and to let you know a little bit or introduce you into some Python programming. So what you should do is when you go into this one is basically work through it from the top all the way to the bottom, reading the information that's contained in the markdown cells and then looking at how the Python that we provided as examples is coded into the code cells and then try to work with it yourselves. You'll also see that we have created some situations where there are examples that you can try out for yourselves, okay? And then also you can basically also do some little exercises. So if you come down, we talk to you, for example, about the concepts of variables and data types, about lists, which are also a different type of data structure that's used within Python. But then here you can also see that we've created some exercises. And after the exercises, we've put some code cells here where you can actually type in your own Python code as a response to doing these exercises. So hopefully that works well, and you can follow these all the way through trying out these different exercises. So that's all I really want to say about this particular notebook. It's just an introduction into how to program in Python. Hopefully you'll find it useful, but any problems that you have, then we can help you out when we do our visits. And if absolutely necessary, we could also arrange to help you remotely by doing Zoom calls as well. And that's something that we can arrange through your teacher. Okay, so let me now move on to the next of the IPython notebooks or the Jupyter notebooks that we're going to be working with. So this one is Kepler Data Intro. I'm going to click on that again, like I did before. And again, you get the same type of Jupyter notebook appearing on your screen that you can work with just through your web browser. So again, we've got markdown cells and we've also got code cells. And what this does is it, first of all, introduces you into how to set up your Jupyter notebook so you can do plotting and mathematical operations using the Jupyter notebook. It's going to give you an introduction into how to read in data file for one of the Kepler systems. You remember I mentioned the system 0069222244. Well, it tells us how to read in the data from that file. And then there's instructions on how to actually plot the data. So I'm going to just execute the notebook in front of me. So again, go into each of the code cells. Just press Shift and Enter. Shift and Enter. That's for reading the data. And now we're going to plot the data on the screen. And bingo, there we go. We get a nice plot on the screen. The nice thing about this type of plot is you can see we've got a button here which switches the plot on and off. And this is a plot which is interactive. It means that we can zoom in and play around with the plot so that we can analyze the data. And that's going to be a really important part of the project. So let me just give you a quick example of that. One of the options that we have here is to zoom in on the data. So in order to do that, I bring my cursor down to this little set of icons below the plot. And the one which is second last from the right or to the right has got zoom. So I just click on that. And then I take my cursor into the window of the plot and I drag it And I can do that multiple times, like this. And what I can see is that the data is consisting of basically some data points up here, which are at around 0. And this just represents the brightness of the star. And you can see while there's some undulation there, that's more or less constant. And then superimposed on that, we've got these dips. One there, one there, one there, one there. And there's a whole bunch of these. When I go back to the original plot, what we can see is that basically this is the brightness of the star over time across the top. And then this data that comes down looks like a bit of a mess unless we zoom in on it. Those data points that come down represent the transits when the planet goes in front of the star. So let me again zoom in. Just on the first few transits, so we get a clear view of what's going on. And I'm going to zoom in again to get a clear view again. And we can see we've got these nice transits here. So the beautiful thing about this is that we can see how deep these transits are from doing this. And we can also see what the orbital period of the planet is, because that's just the time between each of these successive transits. So along the x-axis here, we've got the time measured in days at which the measurement was taken. This is some special units, which I don't really want to talk about now, but they are discussed in the Jupyter notebooks that we provided for you. And here we've got what we call the flux, which is the brightness of the star. And these dips represent, as I've said already, the transits, the time that the planet is going in front of the star and blocking out some of the starlight. So for example, if we wanted to work out what the orbital period of this system was, what we would try to do is just zoom in on a couple of transits, and we just measure the time between them. So another nice thing about these Jupyter notebooks is that when I move my cursor around on the screen, it actually shows me the position in the diagram or in the plot where my cursor is located. And that is printed at the bottom, and you can perhaps see those numbers changing down below, just down here. So what it means is that I can put my cursor here and more or less work out the time at which this transit happened. So in this case, it looks like it's a number of 135.222, roughly speaking. And then over here, I can see the time at which this transit occurred was, well, that's more like 131.709. So taking this number away from that number tells me, roughly speaking, what the orbital period of the system was. So that's going to be very useful for you when you come to analyze the data. There are other features of this interactive plotting which can also be useful. For example, you can move the data along by kind of panning, by going onto this panning icon here, and go back to your original plot like that if you want to. So there's a whole lot of features which I think you'll find useful. Now, one thing I just want to say very quickly about the setup that we've provided for you is that there are two, if you like, formats in which the Jupyter notebooks are presented when you log in. And I'm not quite sure how the system is going to react or respond when you log in. I've set mine up to provide what's called a classical Jupyter notebook style. But the system that we're using also has something which is slightly different than that. It's called the CoCalc Jupyter notebook. And I'm just going to show you what happens when we use that instead. So I'm going to click on that, and that's going to change the format of my current Jupyter notebook to this other type. And when I manage to do that, what you can see, it does look rather different. So it looks, first of all, different at the top left. For example, there was a little Jupyter icon there before that's disappeared. And just generally, the way in which you interact with the Jupyter notebook looks a little bit different in this case. And the reason why we're not using this particular format is that if I again execute these different commands and I go down to the plot, it doesn't generate the plot for us in the way that we want to. And so it's really important that when you use these Jupyter notebooks that you use the right format. So if you happen to come into a format which doesn't allow the plotting to work in this Jupyter notebook, this is the one which is called Kepler Data Intro, then what you need to do is you take your cursor, you'll notice a little plus symbol, top left corner of the screen here. And then above that, there's a word called File. Just click on that, and that's going to open a menu. And what you do is go to the very, very last option on the menu, and that says switch to classical notebook. And then it asks you if you want to do it, and then you do it. You wait a minute or two while the system makes the change. Takes a little while, but hopefully it should work. System is being a little slow today for some reason, but it will come eventually. It perhaps means that other students at the university are using a computer where this whole system is running. There we go. Okay, so it's come up. It just takes a little bit of time. And what you'll notice is this little Jupyter icon comes up, Jupyter spelt with a Y, because this is Python. So we've got this little Jupyter icon, and when that is present, then you know you're using the right type of notebook, the classical notebook. So again, if we execute the commands here, just repeatedly until I get down to the one with the plotting, you see the plot comes up nicely. And we have this lovely interactive plot, which allows us to do the data analysis. So I just wanted to make that point. It's really important. In addition to using the Google Chrome web browser, we also need to make sure that we're using the right type of Jupyter notebook in order to be able to plot the data in the way that we want to and interact with it. Well, we've got all sorts of other information in this Jupyter notebook. I don't want to go through it in detail. There's stuff to do with what we call phase folding, more stuff to do with plotting the data and things like that. I'm not going to talk about it now, but please make sure that when you go into the notebooks that you execute each of the cells at the beginning so that you can start to see everything that is meant to be presented in the notebook, so all the plots that are meant to come up, all of the text which is meant to come up in the markdown cells is properly presented. So sometimes it gets a little bit messed up when you go out of the notebook. So you need to re-execute sometimes in order for everything to look good. So finally, let me just talk very quickly about the other two notebooks before I finish off. So the third one is obtaining planet parameters. So again, I'm just going to double click on this. This is a markdown cell. And this whole notebook is made up of a single markdown cell. And sometimes when I come into this, I find that the text is not presented very well. So I need to double click on it and shift and enter in order to execute it. And then that sorts everything out. Now, the idea here is that you're supposed to just read through this information. There's no programming in this particular notebook. It's all markdown cell, but it gives some information about the project and the different planet parameters that you're able to obtain from the data. So that includes the planetary radius, the orbital period, what we call the orbital semi-major axis, which is the distance that the planet orbits from the sun, usually measured in meters. It's very important when we think about how to calculate these numbers that we're using consistent units. So we will be using the standard SI units, so meters, seconds, kilograms, so on and so forth. Other information that we can get from the data also tells us something about the geometry of the transit. For example, this middle diagram here is showing a planet, which is shown in brown, and a star, which is this yellow circle. And when you have a transit, then the planet can be moving from right to left. And the question is, does the transit take the planet right through the middle of the star, or does instead the path that the planet take create more of a chord like this one here? And this is information actually that we can get out of the data. And it basically can be obtained because we can measure how long the transit lasts for. And clearly, if the planet is moving across the center of the star like this, it undergoes a larger path as it's transiting in front of the star. So that means that the transit duration will be longer. If it's undergoing a chord like this, then the path across the star is shorter, and therefore the transit duration is shorter. And there's some complex geometry associated with this problem, which we can work through, and that basically tells us how to find out about the geometry of the transit just by analysing the data. So if that's something that interests you, then certainly have a look through this part of this Jupyter notebook and try to get to grips with the geometry. It's just using Pythagoras' theorem and a little bit of trigonometry. That's all you need to use in order to understand what's going on there. But I would say the most important parameters that you want to look into are the planetary radius, the orbital period, and the semi-major axis. And then finally, we'll come on to the last of the Jupyter notebooks that we're providing for you. It's called Kepler Guided Exercises. Again, just going to click on that, and I just double click on the markdown cell to make sure the text is properly rendered. And basically what you can see is that there is some information here about basically undergoing a step-by-step approach to analysing the data. You should do these exercises only when you've read through all of the other Jupyter notebooks, when you've gone through the Getting to Know Python notebook and worked on the exercises there, when you've gone through the Kepler Data Intro Jupyter notebook, so that you can understand what the Kepler data is doing, how to plot it, and all the rest of it. And then once you've read the Obtaining Planet Parameters, so you really understand what the different parameters are that can be obtained and how they can be obtained from the data. And then again, using the system KIC 0069222244, these different exercises are given in a step-by-step fashion. You have step 1, which is basically reading the data and plotting the flux. Step 2 is using the zoom function and finding the orbital period. Step 3 is looking at the depth of the transit and using the depth of the transit to work out what the radius of the planet is. Step 4 is finding the semi-major axis, using the fact that we know how massive the star is. So using Newton's laws of gravity and the laws of circular motion, one can work out what the semi-major axis is, or the distance the planet orbits from the star from the data. And then when you want to look at these other geometrical parameters, what we call the impact parameter and the inclination of the orbit to the line of sight, then information about those and the exercises associated with those are provided in step 5 and in step 6. And then you can go to the Exoplanet Archive, which is run by NASA, and check to see how good your estimates are for the different parameters as well. Okay, that's enough, I think, about the different Jupyter notebooks. But let me also remind you, there's a little bit of an overview provided on GitHub about the project. So in the email that I sent to your teacher, we also have a link to this GitHub repository. You don't need to know about the files which are stored there because they're the same as the files that I provided for you. But there is a page here which you can read through, which gives you an overall introduction to the project, some of the ideas that I've just discussed with you already. You might find it useful to read that before you start working on the project. Okay, I think that's probably enough from me. I'm certainly looking forward to working with you all. Good luck in getting started. And if you have any problems, don't hesitate to contact your teacher, who will then contact myself and George, and we'll be able to arrange some help for you. So looking forward to working with you soon. Okay, take care. Bye-bye.